Hi, previously I explained to you how to run fastqc program to analyze quality of fastq files. With this program you make a QC report for every fastq file you have, like this for instance. And then of course the logical question would be, can I get a summary out of all those files altogether? And exactly for this purpose, we can try multiQC program, which is available on Sequera website. And it's nicely illustrated here that every time you create a series of reports for every sample, 1, 2, 3, you can summarize it in a multiQC report. You will find the link in the products, and if you click on it, it will show you what the report will be generated. But the most of the attention should be paid to this little thing where it says pip install multiQC. Pip is a standard installing program for Python, and multiQC is a Python-driven program. And therefore you must know some elementary things how to deal with it. First, you have to know that Python might be pre-installed in your computer. If it is Windows and you didn't install Python, it's not there, but it will come together with Ubuntu if you install Ubuntu for Windows. In Linux, you have at least one version of Python pre-installed as a part of the system. The same story with Mac OS. And in older versions of OS there were more than one versions of Python. And you don't touch those system Pythons, you don't mess with them for many reasons. You have to install your own version. The best way out of my practice is that you install Anaconda, which is a slightly different version of Python in terms of its location on your computer, and it comes with plenty of the most frequently used packages, so no big sweat of missing something. And in addition you install Visual Studio Code, with which you can access Python and see exactly which version of Python you use. I skip installation of Anaconda, it's pretty straightforward. You take what you want, download, install. The same with Visual Code. Then you open VSCode and then open new text file, and then it will tell you select the language, Python. This is just a command. And if you're first time, it will immediately offer you to install a Python module. It is a modular system where, depending on what language you use, you will be offered to install something which will support your language. And in case of Python, you install Python, and this comes as some extra if you like. And for future, I would suggest you, if you will try to program in Python, then Jupyter support is also a good idea. Then you are back to your script. What is important here, let me show you this corner. In this bottom right corner, there is a selector what Python you use. It will show you all the Pythons installed on your computer. Remember that Anaconda Python is yours. You can torture it endlessly and then remove if you don't like it, but do not touch others. This users bin Python 3 is a system one. This is an extra, but I do not remember whether it was me or OS installing it, and therefore I wouldn't touch it either, and I'm sure Anaconda is mine. You select it. And now Python is loaded. You can type pip3 install multiQC, and in a few seconds it is successfully installed. In your case it might be a little longer because it will install also some missing libraries or will have to update some. In my case I did it already before, so it's so fast. We can check the presence of multiQC by typing multiqc --help. It will tell you what you can do with this, but essentially you need to indicate input directory -o output directory. That's the thing. If you type in command line pip freeze, it will tell you all the installed programs in this particular Python. They are alphabetical, and then you will see multiQC is added to this Anaconda Python. It works. What is next to do is very simple. You define input directory where fastqc HTML files are located, and then you define output directory where multiQC will store its report. You can write those directories in your Python script. It's perfectly in style of the Python to define two variables, my or input. Input directory is this. Yours is, I don't know. And then you can say multiQC paste input. Then, just like with the fastqc reports, you say -o, copy this. Here we are. You will find your multiQC report in the output directory. What you see inside is a pretty simple business. It will literally put next to one another all the data picked from separate fastqc data and tell you that statistic of duplicates, GC. This data a bit strange. GC is different by 1 or 2%. How it can be happening, I don't know. It also says that sequence size of the fourth sample is much bigger than others. Here you can see that while number of duplicates is different, number of unique reads is comparable. Nothing is really new or surprising here. You observe the same data of all your samples, but now next to one another, and you can compare things, the quality, etc., etc. Here you can click on a picture and then you will see the more regular line plot, and click back and then it will be a heat map kind of. GC content, as I said, is strangely different upon treatment. It should not be the case. Duplication is all the same, no problem. Adapters and report over all reports in one pretty ugly figure, saying that some parameters like per base sequence content is not perfect, but all data mostly green and surely acceptable for further use. And of course you can say, okay, it's not very convenient business to write it in the command line. Can I do it more civilized way? And the answer is yes. For this I wrote already this little script. It can be actually simplified. That's the script where I tried multiQC from Python, like multiQC run my dear oh dear, but it didn't work. What in fact you have to write is import os. Then indeed define indir and outdir. Then this doesn't work and don't bother. Then you define a command line like multiQC my dear, not my again, ind dir out dir, etc. Or you can even define it like this: copy cmd2 is paste. You just write what you wrote in the command line as one big string, and then you say the reason why you import os package, you say os.system cmd. It will project this cmd2 into the command line, into the terminal. So all fine, all clear. You say run, and then you see the same thing happening. It works, and then you go to check directory. Again, it generated one more time the same data. It's all working fine. For the future, be aware that whenever you have to write the script for the command lines, the usual practice is to write shell scripts, but shell scripts are generally difficult. In many cases, you can use Python scripts which are more user-friendly, and use this trick with the function os.system and send a command to a terminal through this function. That's how it works.